races me to the peak. Can we find any light without the music around? There will always be one love online. Without no love, you got no regret. Without no revenge, you got no love. A melody dancing in your eyes like shadows in the night, doing pirouettes around the stars. We were running in the haze, I remember every shade hit my veins and they shot up sparks. Words fell from your lips and all I heard was white noise in the dark. But when you looked away, I remember every shade, every shade, every shade. So let your colors run tonight. We're painting in the dark. Let your colors run tonight. The
Sorry,
colors
it like
of
auto
your
mute,
heart.
like if I mute it in one song,
Let your
you can hear it
colors
now, right?
run tonight. We're painting in the dark. Let your colors run tonight.
Okay, so let's go ahead and move this in. So we are talking about arrays today. So has anyone ever heard of arrays before? Does that sound familiar? Anyone? Too loud. Down to there. Is that better? Or still too loud? Too loud? Good? I'm gonna assume that means good. Right? That's what that means? That silence means good? Okay. It's hard to remember because I have like a combination of the volume on the... Is it the microphone volume is too low? I'll turn this down to like halfway, maybe? This is actually not fully up. I wonder why. Is that good? Is that better? Much better? Okay. Okay, because like... Okay, so this is good. This is doable. Okay, so we are talking about arrays today. So let me know in the chat if you ever heard of arrays. Hi, True X Living. I don't remember who you are, but how's it going? Okay. So memory. Everyone in here likes having memory, right? It allows us to remember things, like, you know, your name and your birthday and where you live and where you placed your keys and all of that good stuff. But our memory is not perfect, right? So I'm sure your memory is not perfect. Mine is awful. So we have trouble remembering things. So we like to... Oh, hey, Mark. How's it going? So we like to outsource our memory. So does anyone recognize this like very, very ancient technology here that's in this picture? Do you recognize it? Is anyone else old enough to remember this thing? It's a phone book, right? So if you've never seen a phone book, because probably I don't think they make them anymore. It's a book that has like a whole list of phone numbers in it. So there were like several kinds of phone books. There was one that there's like white pages and yellow pages. I don't remember the difference because I'm not that old. So like one of them is people's personal phone numbers, like for homes and stuff. So like you used to like not have like a cell phone where you could like remember like everyone's phone numbers, like and just hit on their name. So you used to have to like look it up. So you would look it up in the phone book. So you'd find someone's number because no one can remember all those things. So memory is very helpful. We need memory, but also it's not enough. So we need to store stuff. And we just need to know where to retrieve things from memory. And so when we're talking about arrays are basically like a list of variables. So we've talked about variables as something that stores something that changes, right? So when we're talking about an array, it's basically like, it's like a variable, except it can hold many, like an entire array of different components. So if we think about like cookie dough, and think about like, if you wanted to like make a shape out of cookie dough, You could like make something manually and then you can make it again and again, but they're all going to be like slightly different and it's going to be imperfect and it's kind of a pain in the ass, right? So if you have something like a cookie cutter, it helps you to do that again and again and again. You can then change the cookies. You could put like sprinkles on some of them, or you could put ginger. I don't know what goes on cookies. Sugar? M&Ms? I don't know. You could vary the cookies, but like it helps you to have something where you can cut something from the same mold. So you can have a lot of cookies very easily. And so like when we use arrays, it helps us to create basically like a list of variables. So like you can make mini cookies this way with a cookie cutter. You can make many variables in a list using an array. So it allows us to do stuff like, for instance, in the example from like last week, we were working with like a bouncing ball, right? So like, you know, we talked about loops were very useful for helping us to do things over and over again. But we haven't talked about how to store many different things. So like if you wanted to use a loop and you wanted to like draw, like for instance, instead of one bouncing ball, say you wanted 50 bouncing balls, you would still have to then make, you know, like 50 variables to keep track of the X, 50 variables to keep track of the Y, 50 variables to keep track of the X speed, 50 variables to keep track of the Y speed, which, as you know, is a pain in the ass and not recommended. So we use arrays because they make our lives much, much easier. So we have to write much less code to do the same thing. So it helps us to do it in a more like automated way, which automated is good. We don't want to do things manually using code. So when we declare a variable, we declare like one thing, right? So like in this case, what type of variable is this one on the top? So this is the value, right? So like, what kind of variable could this be potentially? It has 1 in the box. So like what data type would you store something like a value of 1? You could use several different things, but what do you think? What would probably be best for that? Come on, in the chat. What do you think? Would this be like a Boolean? Would this be like a string? Would this be, what would this be? Would it be like an int or a float? So if it's, so you could actually use a string technically, but usually we probably wouldn't, because when we use a string, we're using something to store text as text. But let's say we wanted to use this as a value, a numerical value. So like, if you were to, for instance, to store something like, so probably not a Boolean, because Booleans can only have 2 possible values, right? True or false. So since it's a whole number, we'd probably use an integer to store a value like 1. We could also use like a float, for instance, but usually if it's only going to be a whole number, an int is probably better because it takes up less memory. Does that make sense? I know maybe it's like the way I phrased the question was a little bit weird. But if you're going to store something like a value of 1, you'd probably use an integer because it's a whole number. So we can store 1 value in that integer if we create it. If we create an array, we can create one thing that contains a whole bunch of values. So we could have, in this case, there are 6 different values in here. So a variable is like one thing, and then like an array is like a list of variables. So this is like 6 different variables. So we might declare it like, we might declare a new integer. So we write int, and then we might call it number. And so the difference when we're declaring an array is that we use square brackets. So like if you look on your keyboard, you know where you have the curly brackets, it's the other one. So it's contained in the same keys. So whenever you see square brackets, just think of arrays. So you're gonna think it's like a list of variables. So in this case, the declaration looks very similar, but we're using those square brackets after the type. So if we're and we can declare an array of integers or floats or strings or booleans or any type of variable we can create. We could also create an array of those things. So in this case, the type is int. The square brackets indicate that we're creating an array, and then the name of the array is number. And so when we declare it, we also need to tell processing how much space to make. So here at the top, we have, we're creating a new array of integers, right? So we have that type first, and then we have the square brackets, which indicate that we're creating an array. Then we have the name of the array that we're creating, which in this case is number. And then we have to initialize it. So we say equals new int. So int again is the type. So if it was float at the beginning, it would be float here. If it was boolean at the beginning, it would be boolean here. It just depends on what type you're using. And then what do you think this value inside of the square brackets at the end of this line references? Why do you think it says 6? What do you think that means? Just based on what you see here. Where do you see 6? Like 6 of what? So you see the number 6, which is a value of 6. Sorry, I shouldn't have said where do you see 6. Look on the top half. Where do you see 6? One, 2, 3, 4, 5, 6. So I'm not sure what people mean by 1 equals 6, 1 of 6. But what we're doing is, sorry, just ignore the bottom half. Sorry, that's my bad. So 6 is the number of positions you're creating. So you see how there are 6 boxes at the top? So it's basically saying create a new array of integers with 6 spots, right? So you can store 6 potential values. So like create a list of variables with 6 potential values. So on the bottom, this is actually assigning those values. So if you were to assign each one, you would use the name of the variable, or sorry, the name of the array. So the name of our array is number, right? So when we declared it at the top, we wrote the name out, so it's number. And then we have the square brackets. And inside of the square brackets, we have an index. So that index indicates which position, which number on the list we are going to. So do you notice anything weird about how it starts indicating which number? So inside of those square brackets, is there anything weird? So there are 6 spaces, 6 different positions within the array called number. Anything weird about that inside the square brackets? So the number inside the square brackets indicates which position that you are referring to. So does anyone notice anything weird? Am I asking too many questions? The numbers inside the boxes are arbitrary. They're just values. So like we have here, when we're referring to the first position in an array, the first index, what is this? This starts at 0. So did anyone notice that, how it starts at 0? It doesn't start at 1. So when you're indicating which position, you would say like the 0 index position, which is the very first one because it starts at 0. That's like kind of the weird thing about like positions of arrays. We start at 0, so like the first one is index 0, the second one is index 1, etc., etc. So actually the index of 5 is actually the 6th position. That's the last position. So it's kind of weird. So inside of the box here, we have an example of a value that we would have assigned over here, right? So when we say equals, we're assigning it to the value on the right. And so when we indicate the square brackets and then the number inside, we're talking about the position within the array, the index. So this particular song is I Don't Know. It is Caffeine Rush by Jacob Tilburg. So again, it's on the playlist for the class. Nobody seems to contribute to it except for Marcus. So Marcus is the expert here. So Yeah. So one thing that we often want to do is we want to use a for loop to initialize all of the elements within an array, and we're going to do that in a little bit when we get to examples. We can also, there is a way we can know the number of positions within an array, so whatever the array name is, and then dot length, if you write that out, like period and then the word length, that will give us the number of positions within that array. So we use arrays for like all kinds of different reasons, and there are different ways to declare arrays. We're just going to use the way that I showed you together. And so we might use arrays for things like positions. If we have many different things, we might have like an array of like enemy positions for like an X position or a Y position. Like I said, if we were going to make like a sketch with like many different bouncing balls, we might have like an X position. So we're storing the X positions for like a bunch of them. We might have a bunch of Y positions that we're storing. We might have a bunch of X speeds that we're storing and Y speeds. So this will save us a lot of time because we don't have to do it manually, because no one wants to do anything manually. I'm just going to skip these. And let's just get into an actual example. And there are also like other uses for arrays. So you can even think about like an image is actually an array of pixels. So it's actually a two-dimensional array. So you can think about each pixel has a different like color value. You can think about that as an array. So it's just basically like a list of things. So I'm going to go ahead and open up. Are there any questions so far? I know it's kind of abstract at this point, but do we have any questions, anything that people are unsure about? Anything that I was like said and then you're like, what? So I'm going to go ahead and open up processing. I'm going to exit out of here. Okay, so let's see, which example should we do first? How about try to do something simple maybe? So it sounds like there are no questions, which I'm sure is not true, but that's okay. Just remember what your questions are, so when you feel comfortable asking, because I'm sure every class people have questions, right? If you're paying attention, there are things that are not going to make sense. So I want to clarify things, so let me know if anything comes to mind. So let's say that we were going to, and if we were to create a bouncing ball like we did before, let's just go ahead and say that we're going to do that again. So we're going to do it in the simple way. So like we might create a series of a float, right? So we might create a float for, if you remember in the example, this is what we did last time. So we might have an X position. We might create another one for a Y position for that, to keep track of the X and the Y position of a ball. We might also create something like speed X. So something to keep track of how fast it's moving on the X axis. We might create one called speed Y to keep track of how fast the ball is moving on the Y axis, up and down. We might create something called diameter. So like some variable that we can use to store how wide or tall the circle is. In the example we used, we created a float to keep track of how much gravitational force to add, and I think we used 0.4 last time, and I could assign this inside of our setup. So I'm going to create my setup and my draw. And so here we go, easy question. What should I put inside of setup? I'm just going to make this. What kinds of things go inside of setup when we create setup? What's the purpose of setup? So size, so like we want to set up the size of the window, so maybe I'll make it like 1280 by 720. So that's how wide to make the window and how tall to make the window. And then what do we want to do maybe with these things inside of setup? So 640 by 480, I could use that, but that's really small on my screen. So what do we want to do with these variables that we created? What do we still have to do for them? So speed X is one of the variables. Is that an emoticon you're using? I can't tell. Or is that supposed to be equals? Colon. I'm not sure what you mean by that. So how about assignments? So we might want to assign those initial values. So we might say like x equals. So where should we put the x on here? Say we wanted to put it in the middle. Okay, so you're giving me examples of some things to create. Oh, you're making it really fast. So let's do x and y first before we get to the speed. In this case, I said speed x and speed y. So again, those are just arbitrary names, right? So maybe for x, I'll put it in the middle of the x-axis. Maybe for y, I'll put it in the middle. Oops. Y equals height divided by 2. So this is half of the width. The width is basically the right side. This is half of the height, so that's halfway down. So that's the middle of the window. We might make diameter, let's say like 150, because we always use 100. And then the suggestion was for speed x to be 50. So that's 50 pixels per frame, which is so fast. So we're gonna have to change that, but I'll go ahead and take that suggestion. And then for gravity, we might use 0.4. That's just how much we used in the example. Okay, so now we are looking at, we want to first, inside of draw, let's say we want to clear our background. So I'm going to write background, and then we give it a color. So if I want to make it black, what number do I put inside of the parentheses to make the background black? What? 0, yeah. And so I might want to set a, or I could do 0, 0, 0. It would do the same thing. Negative 255, negative 255, but so that would be, it gets capped at 0. So I think if you just do if you do like -1, it would just turn it into 0, or negative 20 or 100. So we want to draw an ellipse, right? So I'm going to write ellipse, and then I'm going to use the variables that we created, x, y, and then what do I use for the width and the height? What variable did I create for that, since this is going to be a circle? Which of these variables corresponds to how large to make it? Anyone know? Diameter, thank you. Diameter, diameter. So remember in the other examples we called it dia, so I'm switching it up this time because I noticed that a lot of people are thinking that these are maybe hard, these are always going to be the same, and these are arbitrary, these are just whatever we call them. So we have the x, the y, the width, and the height. So it's the same for both the width and the height. Since it's a circle, so we can see what that looks like. If I drag this over, it's not moving at all, right? And so what do we need to do if we want it to move? What do we have to modify to change the position over time? Which variables do we want to modify? Anyone know? So the speed x is something we want to modify if we want to change the acceleration or deceleration. But before we can even change the acceleration or deceleration, we have to modify the position, right? So the position is x and y. So in our examples, we used like x plus equals speed x, right? So this will take x and then add speed x to it. And then we could do the same thing for y with speed y. So like if we run this now, you can see it move very, very quickly because speed x is 50, meaning 50 pixels to the right each frame, and 50 for speed y, meaning 50 pixels down each frame. So if it's 60 frames per second, that means you're not even on the screen for a second before it goes off the screen. So if we wanted to make this bounce like we did last week, we could check if our x position was greater than the right side. So the right side is width, right? And then if we wanted to, well, I'll just do this for now. And then if it is, what do we want to do if the x position of the circle hits the right side of the window? What do we want to change? And while you're answering that, I'll go ahead and do the other sides. So if I want to check if it's like to the left, so I can check if x is less than 0, meaning the left side. And then I could check if y is greater than height to make sure it does not go out off the bottom. And then I could check if y is less than 0, meaning it's like gone off the top. So when we're checking if x is greater than width, meaning it's gone past the width, what do we want to change about x? Because x is being moved to the right because speed x is positive. So what do we want to do to speed x to reverse it? How do we make anything that's positive negative and anything that's negative positive? How do we modify things in that way? Let's say it was 500. How would you make 500 negative 500? Does anyone know how to reverse that? Let's say you have 100. What would you have to multiply 100 times to make it negative 100? You would greater than? So negative 1. Thank you. So like if it's negative 500, if you multiply times negative 1, it becomes 500. If it's 500, if you multiply times negative 1, it becomes negative 500. So I want to modify speed x by multiplying times equals, take the value it has, and then reverse it, basically. And so I also want to do this with this one, so speed x times equals negative 1. And then for this one, when y is going beyond either the bottom or the top, what do we want to do here? What do we want to reverse here? Do we want to reverse speed x? Or do we want to reverse speed y? Or something else? Or... So if it's positive, we want to make it negative. If it's negative, we want to make it positive. So what would we multiply to reverse the direction it's going for the y position? So if we did this for the x, if we multiplied speed x times negative 1, so we want to reverse not the y because that's the position, right? We want to reverse the speed of y. So similar to how we did speed x multiplied times negative 1, we want to do the equivalent for speed y. And so it's the same thing here. So either way, regardless of which way it's going to reverse it. And so let's see if that works. So as you can see, it's going very fast. So maybe we'll make it a little bit slower. Maybe I'll make it just like 5. So you can see it's bouncing off the sides. And if we wanted to, I'll just leave it like that for now. Let's say that we wanted to add in the gravity like we did before. So we want to add gravity to speed y. So speed y, because remember, gravity is a constant downward force. So to move something down on the y-axis, it's a positive value. So if you add, so plus equals gravity, that's a constant force pushing it down. So now it has that arc, you see? So when we wanted it to, so this is like kind of where we had it before. We had it slow down each time it bounced also. So instead of, when we had it hit the bottom, which is y is greater than height, instead of making it 1, we would make it like 0.8, I think is what we did in our example. And we also slowed it down to make it 80% as fast for speed x. So basically it's like slowing down both aspects. So let's see what that looks like. So now each bounce is a little bit less than the previous bounce. And then the final thing that we had to do to make sure that it didn't go through the floor, because you see how it's going through the floor. So it bounces, 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 and then it starts going through the floor because that gravity is still pushing it through there. So what we did here is we took the y position and we said make it equal to height minus the radius. So that's diameter divided by 2. So this might be funky because we didn't the other side. So we also, so this is the simple way to do it. Since it still goes off screen a little bit, we needed to compensate for the radius. So we needed to say, because X is the center of the circle, right? So we want to tell, not if it goes past the right side, but we want to tell if it if the circumference, if the edge of the circle hits the width. So we can either take width minus the radius, which is diameter divided by 2, or we could say x plus the radius. Either way would give you the same result. And so for this, we were checking if x was less than 0, so plus the radius. That's diameter divided by 2. For the y, we want to check if it's greater than height minus the radius, again, because we need to consider the radius if we want it to not go through there. And then if y is less than 0 plus the radius. And so this gives us what we got like 2 classes ago, right? This is what we did together. And so now it's just sitting there, it's just chilling. So we have like some basic bouncing ball. So this is all review, right? All stuff we've already done multiple times. So if we are going to convert this into, if I wanted to make 50 bouncing balls, if I was to do it this way without using arrays, it would take a very long time, right? It would take us as long as we did times 50 probably. And so we don't want to do that because that's a pain in the ass, right? So what we can do is, first of all, I'm going to create a variable to keep track of how many we want to create, so how many positions within our array. So I'm going to make it, it's going to be an integer, so I will make it like, I'll call it how many. So, and in the beginning I need to give it a value, so we're just going to create 10 for right now. And then when we want to convert this from regular variables into arrays, what we want to do is we want to write, so I could create an array this way. So that will create an array, but I also need to initialize it, so equals new float. So again, when we want to initialize it for an array, we use the square brackets and then equals new and then the type again. So since these are floats, we write float again. And then inside of the second square bracket, we indicate how many positions in the array we want to create. How long is this list going to be? So we created the variable called how many to do that. So I'm doing the same thing here and here. So these are all floats. So I'm just writing equals new float. How many? So this will create, instead of creating one variable for x, it will create an array of floats called x, and it will create 10 different positions within it. And it's doing the same thing for all of the other variables. So we're converting it from a single variable into an array of variables. So I'm just like literally doing the same thing to these other ones. I mean, the diameter, we could make this an array if we wanted to, but if they're all going to be the same, it doesn't matter. So now we want to think about, like, if we want to, because here we have where we're actually, and I'm going to move this line of code so that we can separate this out. So in this case, this is how we assign individual variables values. But if we want to assign many different variables values, if we want to do it over and over and over again, a loop will help us do that easily. So loops are good at doing things over and over and over again. So I'm going to go ahead and create a for loop. And so if you recall, inside the parentheses, the first thing is to create a variable. So I'm going to declare an integer. I'm going to call it I and give it an initial value of 0. And then semicolon, the second piece is the test condition. So as long as this test condition is true, it's going to run the loop again. So as long as I has a value of less than x dot length. So remember in the slideshow, I said the array name, whatever it is. So in this case, x dot length will give us the number of positions within the array. I could also, instead of saying this, I could also say how many. So that's based on the number we used at the top. So either way will work. And then the third thing is the update. So how is it going to update each time the loop runs? So if we increase I by 1, and so we still need to fix this because these still x, y, speed x, speed y, these still refer to single positions within single variables. So if we want to switch them into arrays, so we need to use the square brackets. Don't forget square brackets, array, square brackets, array. Have that association in mind. So we use the square bracket after the variable name, and then inside of the square brackets we indicate which position. So since we're using this for loop, we're going to use I because I is going to be 0 the first time it runs, it's going to be 1 the second time, 2, 3, etc. And so that will actually give us an assignment for each of those. And so one thing is that if we do it this way right now, all of these actually have like the same positions and the same speed. So they will all be overlapping, like stacked. So we want to make these a little bit different. So instead of putting them all in the middle of the x-axis, what we can do is we can use random. So if we use random, we could do width. So if we write random, inside the parentheses, it takes a number that is the limit. How far? So between 0, so this will give us a random number between 0 and width. So that's like somewhere between the left side and the right side of our window. And I'm just going to make these speeds 0. So it'll be affected by gravity, but it's not like being pushed at all. Are there any questions? Let me know if you have questions. I expect you to have questions. Throw your questions in the chat. No question is dumb, no question is stupid. All questions are valuable. Okay. So now anytime we're referencing these things, since we want to do it for all of our arrays, we're going to want to use for loops again. So for loops will help us go through each of the positions in the array. So I'm going to do the same thing like I did above. Int I equals 0. I is less than how many. Could I make the gravity like 100 from each? I could make it 100, but that would be like, you know, like Jupiter gravity. it would be like really crazy, like so fast that you wouldn't even notice it. It might even glitch out actually, because gravity is like a very, remember that it's happening like once every frame. So over 1 second, that's 60 times. So that would be 600 pixels down. It's pulling it every single second, which is, it's gonna pull it all the way to the bottom within a second. We can try it once we finish this. And then we can't use dia instead of diameter. So that's just, I named it diameter because I wanted people to know that, like, like if we call this x speed or speed x, it doesn't really matter if we call this pose x or pose or x. It's arbitrary, right? It just depends what name we gave it. So that's why I switched it up a little bit, because I want you to remember that these are arbitrary. These are just whatever we called them. I could call, instead of diameter, I could call this walrus if I wanted to. And then everywhere I refer to it, I could just write walrus. I don't write walrus because that doesn't help us know what it is when we're reading the code. So in a previous example, I might have called it dia for short. And this time I just used diameter because I want people to know that it's just whatever name we gave it, right? Does that make sense? Wait, no, I mean each side acts like the ground when the ball is a certain distance from them. Oh, you mean like, so like the balls push each other away? Each side acts like the ground when the ball is a certain distance from them. So that's what we're doing, where we're checking if the, where we're checking it with the radius, when we're offsetting it by the radius. So I'm not sure if I understand the question properly, but so I'm doing the same rules we did above in side of setup, and then I'm going to add my closing one. And so all of these are underlined because these were all the way we did it previously, which were for the single variables, but now we want to use the array version since we've made them into arrays. So I'm using square bracket and then I, which is the position, so the index. So if we use that, then I, we know the first time the for loop runs, I is going to have a value of 0. Then I is going to have a value of 1. Then it's going to have a value of 2, because it's going to add 1 each time until it has a value of 10, and then 10 is no longer less than how many, so it'll stop running. So it'll do it very efficiently. It'll do it for every single one that we have. So all I'm doing is converting these into array versions. So I'm just adding this to each of the variables that we've already created. And you can see that the red underlining goes away each time. So now let's see what we got. We have an error because I forgot to correct this one. So this should also actually be inside of here, because we're gonna have to draw each one of those circles. So we want it to be inside the for loop, because if we have it outside the for loop, it's just gonna draw it once. So now you can see we have all of the balls are falling, and they're all falling at the same speed, and they have nothing on for their y speed, so they all basically like act the same way. So how could we change this up to make them move differently, so that they're not all falling in sync, which looks weird because nothing is ever perfect in real life. Like if you were to drop 2 balls, you would, unless you're like a robot or something, you wouldn't be able to drop them at the same time. So we could, for instance, we could change the initial x speeds if we wanted to, or the initial y speeds. So I could make this like a random value for this, so similar to how we made it a random. So notice how like when we use this random x, they're always in different places, have their graves at random. Are we talking about different kinds of gravity? Is that what you mean? So one thing about the gravity is that, I mean, we could have we could make an array of different gravities to affect them, but that's like not how we see things in the world. So like different things, and things technically do have different gravity, but like we expect things to fall at the same speed when they fall from like a rooftop or something. So we expect gravity to affect things the same way. The only thing is that like we don't expect these to be perfectly in sync. So we can change, for instance, if we wanted to change this speed x, we could make this a random value as well. So if we use one parameter for this random, so I can make it like 10, that would give us a random value between 0 and 10. So let's see what that looks like. And so you can see that that's moving it differently here. I can run it again. And so they're still bouncing in sync. So I could also make it something where I give a random y position, or I could give it a random speed y, so I can make this a random value. So if I say 5, that's a number between 0 and 5, so roll a die, 0 to 5, this one. So now you see that like they're all bouncing slightly differently because they all start off with different speeds. So can everyone see that? How they're always randomly generated. Another thing I could do is, one really great thing about like using arrays in this way is like if we wanted to create, remember that like if we wanted to do 1, we did everything for 1 to begin with, and now we turned all of our variables into arrays, all the ones that would be used for a separate ball. And so if you wanted to do that manually, remember you'd have to write it out so many times. So if we wanted to change this, instead of 10, let's say we wanted to have 100 different balls. So this is going a little bit slow, but you can see now there are like 100 different balls that are all bouncing, and I could run it again and they're all going to be slightly different. Is there a way to make each side act like the downward position? I'm not sure what you mean by that. Each side act like the downward position. You mean like basically like switch gravity, so it's like the right or the left or something? Is that what you mean? So I mean, we could do that. I don't want to confuse people, but for instance, we have gravity right now is affecting things by, when we apply gravity, we're applying it to speed y. If I change this to speed x instead, it might give us a weird glitch, but let's just see what happens. So if I change it to affect speed x instead, you can see that now they're all bouncing to the right side. So it's positive still, so that's why it's to the right, because positive on the x-axis is to the right. So yeah, you just have to think about like this is affecting things on the y-axis, so maybe 100 is too many, maybe like 30 is a good number. So yeah, I mean, you could make, all you'd have to do is just change this number, and we've made it in such a way that it will create more and more. So I could make 300, which is, you can see it's like slowing down a lot because it's a lot to calculate, which is why I kept it at like 30. We could also make them like slightly transparent if we wanted to, so that you can see through them. So maybe like fill value of like 255.50, so that's white, and then an alpha of 50, so that's pretty transparent. So now you can see through them, so you can see how many there are behind the others. If I wanted to have, I could use no stroke. If I wanted to not see the outline, for instance. So are there any other questions about what we've done together so far? So now I'm going to add the interactions that we did on Monday together in class. So if you remember Monday, we created the mouse interaction for the homework as an example of one way to do it. So what we used was dist, remember? So we created like a float called distance, and then it measured the distance between the center of the circle against the cursor's position. So in this case, we might want to check the dist. So it takes 4 parameters. The distance between the first point in space and the second point in space. So the first point in space is mouse X and mouse Y. And then the second point in space, and since we're using arrays, we want to use X square bracket I. So that will go through each one, and then Y square bracket I for each one on the Y. So this will give us the distance between the cursor and each ball. So it will tell us each time, it will calculate that for us. And then we want to check a condition. That condition is if the distance is less than the radius of the circle. So to get the radius, we take the diameter divided by 2 is the radius, right? Half of the diameter. And so if you remember, we had where we were able to use the previous mouse position to like kind of control the speed. So we used we did something like speed X, and then we're just doing the array version equals the current mouse X position minus the previous mouse X position. So like this will give us the positive or negative for, because like how you can determine how far it's traveled. So we'll do the same thing for speed Y. So let's see what that looks like. So this is all the stuff we've already done before, right? So this way I can make it interactive, right? So you can see how they are connected to the cursor. So this is just what we did last time in class. So I can just sort of play with them a little bit. And so you basically just like catch them. So this is all the stuff we did before. The only thing is we've like put stuff inside of a for loop because we want to do it many times. And then we've changed each of our variables for the X, the Y, the X speed and the Y speed to be the array versions. So not just a single one, but an entire list of different ones. So we could also, for instance, we could set a fill value if we wanted to. So like this is basically like if it's touching that ball, that's why we take over the speed. So I could also set like a fill value of, I can make it just like 255, and then I could have like an else here. So this is like if it's actually hovering over it, it will do this stuff, and I could move this into here. So this would happen if this was false, meaning that the cursor is not hovering over that particular ball. So now you can see it like sort of highlights which ones are being controlled right now. So you can see this, they're still like falling through because gravity is still affecting them. It's still pulling them down. But I could just like, you know, mess around in here, make it fun. So does it make sense how we applied arrays to this? How we basically just like, we put everything inside of for loops. We changed the declaration at the top to be instead of like float X, we basically, this is doing the same thing except it's setting it up as an array of floats. And we're indicating how many positions within it, so it knows how many spaces to create. So we did that for all 4 of those. Yeah, so let's see. I could, let's say we wanted these to be, we could also create, I'm trying to think of what would be useful. Does anyone have any ideas for how you would want to maybe like control these? Anyone have any ideas? I'm just going nuts here. Okay, that might be too much fun. Make the mouse like a bumper. So I could, for instance, like let's say instead of using the cursor to be like if the cursor is hovering over it, I could make, if I'm interpreting this correctly, I could make it like there's like a circle that you're controlling the circle. So instead of, so I could basically draw, I could draw an ellipse around where the cursor is. So I could use the mouse X for the X position, mouse Y for the Y position, diameter for the width and diameter for the height, and then I could use a fill value of like 255, 70, 50. Let's just see what that looks like, so that you can still track it visually. And then instead of checking if the distance between these things is less than the radius, we could check if the distance between them is less than the diameter, because let's see, where's my, I can open up my drawing tool. Oops. Okay, so like when we were checking the distance between, like we had like a circle, right? And then we had the X and the Y of the center, and then we had like our cursor, right? And we were checking the distance between them to tell if that distance was less than the radius here, half of the diameter. So if they both have like the same size circle around them, so let's say, sorry, that didn't, just imagine that's the same size as the other one. So then the distance between them, in order for it to connect, would not be based on half of this, it would be based on the full diameter, because it would be this amount plus this amount. So those together would be the diameter. It says diameter. So let's see. So now you see, like when I come close to something, I don't have to touch it. All I have to do is get close enough to it, and it starts to connect it. Is that sort of like what you meant? I have to have my, where's my cheat sheet with all of the people's usernames on them? Cool. So we could also have where there are different things we could do. Let me see. So like this is one thing that I've done where they like actually go off screen, and like every time you touch one, it stops. That's like pretty similar to what we've done. So I could see. So I'm going to take this and I'm going to copy it and move it into a new window so that I can get rid of some of the stuff. So all of this stuff was making it bounce, right? So that was making it bounce off of the right side, making it bounce off of the left side, making it bounce off the top and the bottom. So if I get rid of that, it won't bounce. If I get rid of the gravity, so I'm getting rid of that. So let's see what this looks like. Oops. So now they're all going off screen. So here's where we were checking if if it was close enough to it. So maybe instead of adopting the speed of the cursor, maybe we want to just freeze it in space. So what would we do to speed X and speed Y for each position in the array? What would we do to it to make it stop moving? What speed would it need to stop moving on the X and the Y? It's the same value. So like what corresponds to no movement? So we would like speed X. Thank you, 0. So a speed of 0 would mean don't move at all. Speed Y, square bracket I, equals 0. So that would actually freezes them in space. So like we've just like basically caught those and now they're not going anywhere. We could also have it where it just like reverses it. So if I wanted to reverse the X and the Y speed every time I interacted with it, then what would I need to do to that value to make it the opposite? If it's positive, make it negative. If it's negative, make it positive. What would I need to do that for both speed X and speed Y? We did it before, remember? We did it when it bounced off the sides, from the top and the bottom. So multiply times -1, so we could do times equals -1. I feel like this class, we always like, everyone's like kind of like cold in the morning as far as like, you know, maybe like not processing as well. And then by the end, I feel like people start to flow better and starts to make more sense. Hopefully that's what's happening here. So like now, when I hit it, it's reversing. So if I hit it again, it's switching directions each time, right? So I could do it again. And the thing is, like, it's doing it every frame that it's inside of it. So that's why it's like doing that like jittering thing. You see how it's doing the jittering? So if I wanted to move it in the opposite direction and faster, we could make it times like 1.1 or something. So that would be 10% faster. That would be 110% in the opposite direction. So I'm just like changing this in different ways. So you see how they start going faster now? So just trying to make like interesting interactions. We could start them off really slow as well. So like if we wanted to make it, instead of making it between 0 and 10, we can make it between 0 and 2. And then instead of making it between 0 and 5, we can make it between 0 and 2 as well. So that's the setup one. So now, the more I basically hover over it, the more speed it gains. So I could also slow it down if I wanted to. So instead of multiplying times -110%, I can multiply times -90%. So that's 10% slower. Oops, sorry, that should be 0.9. So now they're moving slower and slower each time. You can see some of them are still moving a little bit. I could also make them, I don't know, I can make them do all kinds of things, and now they have basically like they're storing their own individual things for their X's, their Y's, how fast they're going on each axis. I could also store something like, I could store a color, for instance. Or I could store whether it's like on or off, for instance. So like, what kind of variable could we use to keep track of whether something is on or off? What type of variable? True or false? What kind of variable has one of two values, true or false? Does anyone remember? So if we'll check a condition, right? It'll check if a condition is true or false, but what is the data type? What type of variables do we use to store true or false? Does anyone remember? This is the B. We haven't used it very much. We just used it like one class maybe. Boolean. Yeah, you got it. So we could create an array of booleans for each one. So we could say like movement on or movement off. For instance, movement on, square brackets equals new boolean. Look at how many. So we could basically like have them where it turns them on or off. So I could give those, do we want them to start moving? Do you want movement on to be true to begin with or false? Like, do you think they should start moving when the game begins, or do you think they should be frozen at first? Which one do you think? What do you prefer? Frozen or moving? To start with. And then we'll have the player interact with each one. Frozen? Okay. So then we would make it false because we're going to be able to use this to check if we should move it or not. So if we scroll down to where we actually have this movement happening, which is right here, we could then check if movement on for each position. So square brackets I. So if this is true, so if we just put it inside the parentheses, it's asking if this variable, if this position within the array is true, then modify this position, increase the position. So if it's false, it won't do anything because it'll just say, okay, this is false, so it will skip this and then nothing will happen. So if I run this, nothing moves, right? It's all still. So if I wanted to make these like freeze, for instance, let's say I wanted them to freeze whenever I clicked on it or something. Does anyone know how we might go about doing that? Make it freeze. Does anyone remember what we use to be able to tell if someone has clicked or not? What kind of function we use? Does anyone remember? Mouse pressed, right? So we could, if we wanted to do it, if we did it inside of draw, it would give us some weird behavior. So we could remember that we could create, oops, mouse pressed, right? As a separate function here. So this will run automatically whenever the mouse is pressed. So processing knows when you include this, any code you have inside of there will execute whenever the mouse is pressed. So if we want to, every time the mouse is pressed, we also want to check if the distance is close enough to be able to tell if you're clicking on it, right? So I can like literally just like copy what I've already done here, which was running the loop to check for each position within the array, which was checking the cursor position against the position of each circle, and then checking if it was close enough, then do a thing, right? So I could check. So I just pasted it in here. And then if we want to, if it is hovering over it, we could turn movement on. So remember how when we want to reverse a number, we multiply times -1, right? So if we want to reverse a boolean, so if it's false, make it true. If it's true, make it false. We can do give it an assignment, which is not. So remember, not exclamation point means not. So since it can only be true or false, if we do this, we're saying take whatever value it is and then assign it not itself. So if it's true, make it not true, which is false. If it's false, make it not false, which is true. So that will reverse whichever way it is. So I'm just going to comment this out for simplicity's sake. So nothing is moving. If I click on it, it starts moving. If I click on it again, it freezes. So I can basically, and since I'm hovering over many different ones at any one time, that's why it freezes like a bunch of them all at once. Maybe instead of no stroke, I can do like a slight stroke. So I could do like 30, 50, 70, 50, let's see. Oh, sorry, I set it up here. So we have a little bit of like a red outline here. So every time I click it, it either stops it or starts it, because it's basically switching that boolean from true to false. If it's false, make it true. If it's true, make it false. And so you can like store a whole bunch of information here. So do people see how these can be useful using arrays? We can do many things very easily. And that's what we want when we're using code. We want things to do as much as possible with as little code as possible. A good coder is a lazy coder who gets the job done. So are there any last questions about what we did with these examples? With how we changed it up? Any particular things like how random works, or how we write the syntax for an array, or how the loop is running, or what are your questions? Last chance of the day. So that's the application, the example that I used, grabbing variables with other variables. So we were using, it's the same thing we did before, kind of, where we were checking for a single one. But now with arrays, we can do it for many very easily. So it's the same thing we've already done. And we could have done this same example with just one before. But it makes it so much easier to do it with any number of them that we want. So now it's a lot more powerful. So it just allows us to store lots of information. So we're just storing information about a whole bunch of different circles instead of just the one. Cool. So any other questions before we go? Bouncing ball. Okay, if there are no more questions, I'm going to post your homework after class today at some point. I have another class from 2 to 4:45, so probably after that. So it's going to be basically to keep track of, you're going to have I'll explain it. You're going to be using arrays with loops to keep track of many things. So another example of what we did together in class. Also, before next class, make sure that you go to the homework that people submitted that was due this week and add a reaction to the one you think is best executed. Only vote once, and we'll go over that next week on Monday. I hope you have a great rest of your day, and I will see you next week. So, goodbye.